Dude,
Hey, how you doing?
good. How's everything going?
It's going all right. It's weird. We haven't spoken to each other in like 10 years and then to hear your voice in this context. Anand and I, we go way back to like junior high and we kind of lost touch somewhere around the time that you started law school and I started med school. There are a number of ways that I could embarrass Anand in this podcast. We've recorded rap songs together. We worked at Friendlies together, where we committed unspeakable acts of rebellion against the management.
I strongly recommend against seeing at Friendly's.
This podcast is helpful in so many ways. It's a great resource. Before that, we worked at Carey Memorial Library together in Lexington, where for fun we would often swap the jackets of books in order to fool innocent library goers. And we have been interrogated by the Lexington police because we were hanging out at the library long after closing because we were pretty rough kids.
Yeah, and Lexington is a rough town.
You got to watch out.
Yeah.
I was once pulled over for having a wobbly license plate.
And that probably made the police blotter.
Yeah, Lexington's a rough place. At the edge of town, there's a sign. Actually, it says "Thank you for leaving Lexington." Oh, and so maybe most relevant to this conversation, though really not very relevant at all. We used to hang out at the local bowling alley, Wallex, where we would often ourselves become automatons, spending hours perfecting our two-man gauntlet game, usually playing on a single quarter.
Yes.
And now you are senior counsel at Google working on autonomous cars.
Yep, that's my project.
So Anand, thanks for hopping on the Device Squad podcast, the podcast for the mobile enterprise from Propellix.
That's great to be here.
Device Squad, fighting crimes against enterprise mobility worldwide. Bad UI, frustrating user experiences, poorly conceived mobile strategies, we defeat them all. This podcast series will cover all aspects of enterprise mobility, including strategy, development, design, testing, and more. My name is Steve Brickman. I'm a mobile strategist and UX architect with Propellix. First, a brief history of the company. Founded in 2011, Propellix is a mobile strategy consultancy helping enterprises worldwide devise true mobile strategies and develop world-class mobile applications across all industry verticals. Propellix clients include large companies like Amway, Bright Horizons, Bank of Montreal, Dubai Airports, Family Dollar, DLL, Cintas, Merck, and many more. Propellix menu of services includes 8 different mobile kickstarts, covering everything from mobile strategy and road mapping to MCOE to UI UX design to mobile testing strategy, along with soup to nuts app design development and support. Additionally, Propellix offers 3 homegrown enterprise mobile products. So I'm just going to read from your LinkedIn profile. It says here, Anand Rao is lead counsel for Google's self-driving car project and a few other early-stage confidential projects, and that your primary responsibility is providing product counsel support for the self-driving car project. Your work ranges from ensuring compliance with federal automotive safety standards, state autonomous vehicle regulations, state vehicle code requirements, and other federal and state laws and regulations, to providing advice on state and federal legislative policy initiatives and legal and regulatory hurdles to potential business plans. You also provide legal support to the self-driving car project on commercial matters, including deals with strategic business partners and suppliers. That sounds like a lot.
It is a lot. Yeah, it is a lot. When you just read it back, I realized that it is a lot.
So take me through your career journey up till now. Tell me how you wound up at Google on the autonomous car project.
I worked at a couple law firms. I did litigation for a couple of years and realized that was a horrible job. That was in Los Angeles. And then I moved up to Silicon Valley and worked at a firm here doing corporate work, representing startups, mainly in like getting financing. So private companies getting venture financing and then taking them kind of through their life cycle. So, some got acquired, so you'd work on M&A transactions, and then some went public. So you'd work on their IPOs, and then you'd work on their kind of public company reporting issues and security issues after they went public. From there, I left and moved to an in-house position at IBM, which was kind of like a product counsel position. It's more not securities, it's not like financing, it's more working with engineers and product people on their products and just making sure their products are legal and dealing with any kind of legal issues that they have. And then in 2007, I moved to Google. I was also kind of like a product counsel position for Google products. So I worked on a bunch of different stuff. I worked on Google Books, Google Maps, Google Travel, Finance, like the Google Finance website. And then in 2012, I started working on at what's called Google X, which is Google's research lab, where they kind of work on strange projects like Google Glass was in there. If you remember that was like that kind of failed heads-up display. And then the self-driving car project is in there. And then the current public projects, there's the Internet Balloon project, which is called Project Loon. And then there's a drone project, which is called Project Wing. Those are the public projects. They've grown enough that basically I now just work kind of 100% on the self-driving car.
Oh, nice. And can you tell us about any confidential projects that you're not allowed to tell us about?
Yeah, definitely. No, there's some things that I can't talk about. There's some formerly confidential stuff that now no longer confidential. So there was a barge project, which in Boston you probably didn't hear about this, but It made a lot of news out here. And in New York, where we also had a barge. So the plan was they got a couple barges and they were going to use them for kind of glass marketing stuff. And they kind of built them up. They were going to build like, basically showrooms and other things on these barges. And they ended up abandoning the project after a couple of years. They kept it secret, except that there was this barge being built in San Francisco Bay. And, you can't really hide that. So after a while, we started getting a lot of questions from the press as to like what this thing was, because people were wondering. And it wasn't really connected to Google. It was just like there was this barge being built up in San Francisco Bay. And then eventually it came out, it somehow got connected to Google, and then we kind of got outed. That was an interesting project. And then I worked on another formerly confidential and also dead project. It was a tileable display technology project that ultimately folded.
How many lawyers are on autonomous cars? Like 1 million?
No, it's not. No. It actually was just me until July. And then they're going to be spinning out as an independent company at some point. And so they hired a general counsel to basically be their main lawyer going forward. And then I'm still the lawyer basically on it until they actually spin out.
That's incredible.
Yeah, it's only 2 people. I mean, it's a lot of work, but it's not as crazy as it sounds because they don't actually have a launched product. So, I think if they had a launched product, they would need a much, much larger legal department with a lot of specialists in areas that I don't really know.
Yeah, so I've been wondering about this. Like, so you guys have autonomous cars like on the road in like San Francisco and Pittsburgh, I think.
Uber has them in Pittsburgh.
Oh, that's right.
We have them we have them out here in Mountain View in the general area, San Francisco area. And then we have some in Phoenix and some in Austin, Texas, and then some in Kirkland, Washington.
So I can't go and drive a car unless I go and take pass a driving test and all that stuff. So how are you guys able to take these cars out on the road and test them, given that it's not a fully perfected technology?
Yeah, that's a good question. So we have test drivers in all the cars. So even though the car is driving autonomously, they're like expert drivers. So they're kind of trained to take control of the car. If they sense anything is wrong or they even feel uncomfortable for whatever reason, they will take control of the car. And they also have a readout next to them that shows what the vehicle kind of sees. So the vehicle has all sorts of sensors on it. It has a laser that rotates 360 degrees, many times per minute, that images all the objects on the road around the car. It has radars that detect objects and their relative speeds and how close they are to the car. And then it has cameras that also recognize objects, and they recognize road signs and traffic lights and brake lights and things like that. So there's all sorts of sensors, and there's a UI that kind of shows what the car sees around it. And so the driver actually can see what the car sees and kind of roughly anticipate like what the car is responding to. And if the driver thinks the car is not responding properly, he or she will take control. So technically the test drivers are the drivers. And so, if the car violates some law, basically the driver would be the one who ends up getting the citation.
And so did you really have to bone up on your technical knowledge? Like technically, how educated are you on this thing?
Yes and no. I mean, like educated in the sense of I had to learn how the car works and, exactly how it operates, what the different sensors do and what the processes are. But, not like I definitely don't have in-depth technical programming knowledge or anything. It's like a non-scientist, non-engineer's knowledge of the technology.
Where do you think Google is sort of targeting or grooming these autonomous cars? Like for what purpose? Is it mostly for commercial use, like to create sort of autonomous taxis, or are they thinking more personal use, or are they thinking even larger than that?
So for us, the business plans are they're not fully certain. I think they're considering many different options. But, you can see, I think just looking at the industry, there's kind of two paths that companies are going down. So there's the Tesla route and probably like the general automaker route, which is kind of like an incremental route. So they're basically adding features gradually and expanding features gradually and just sort of continually selling cars and then progressively rolling out features, in newer models. So like Tesla just recently announced that they increased the suite of sensors on their next model year of cars. And they're claiming, that the new sensors will be able to do a lot more than the old sensors and give the cars much more capability. So that's one route. Just to give you a little bit of background on this, there's a classification that's used for autonomous vehicles that goes from level 0 to level 4, with level 0 being classified as like a car that has no autonomous capabilities, to a level 4 car, which basically doesn't need a driver. It can operate fully autonomously in all environments within its kind of operating domain. And then between that, you have varying degrees of automation. So like a level 3 car, it operates autonomously, but it's not safe enough to operate without a driver. So you still need a driver behind the wheel to take control in case something goes wrong, but the car supposedly can operate autonomously. A level 2 autonomy car is what you're seeing on the road today. So Audi, Mercedes, a lot of the really pricey high-end cars have level 2 systems, and even lower end cars now you're seeing mid-range cars are starting to roll out these capabilities. You see traffic jam assist. The car will sense the car in front of it and keep a certain distance from that car. And if the car in front of you hits its brakes, your car will also hit the brakes and keep the same distance. And lane keep, and that is the car detects kind of where the lane barriers are, and it'll keep the car in the center of the lane. So if you drift off or something, if you kind of fall asleep, the car supposedly will stay within the lane. So Tesla's autopilot, that basically is a combination of traffic jam assist and lane keep assist. So basically it's designed to drive within the lane and not hit the car in front of it. But that's still a level 2 system. So it still requires a driver to be, totally alert and driving most of the time. Google's shooting for a level 4 car. So this is the other of the options. So like I said, existing car makers, they're mostly going with this incremental approach. So, you'll see level 2 cars, and then sometime in the future, you'll probably see level 3 cars. And then eventually, way into the future, you might see level 4 cars. Google, since it doesn't sell cars and doesn't make cars, is trying to go right to level 4. So they're trying to design a car that really doesn't need a driver at all. So you can kind of get an idea of like where that would be used. So like for a level 4 car, those are less appealing to people like you and me who are going to buy cars, right? Most people don't need a fully driverless car.
I do need one of those.
I mean, yeah, you could use one, certainly. It would be pretty cool to send a car to pick your kids up from school or something, right? So now the thing is, like, if you think about it, you could definitely use those features, but you probably don't really need to own that car.
Right.
You actually just need it for 30 minutes a day, say, to like run it or whatever. But then the rest of that time, the car is going to be like in your garage or in a parking lot, or, most people drive their cars just, a very small fraction of the day. And the rest of the time, the car is idle. So if you have a level 4 car, you can maximize its utility. You can keep it up and running 24/7, arguably. And it would be probably better used in like a taxi type service or an Uber type service. You can see kind of like roughly what the options are. And then for a company like Google, you could try to license the technology to car makers. So there's lots of options, I think, that are open to the company. But right now, they're just trying to work on the technology and perfect the operation of the car before they actually do anything on the commercial front.
Do you envision a time when there'll be no reason to own a car at all? Is that something that Google is shooting for?
Yeah. I mean, it's not necessarily something Google is shooting for. I think that's just sort of where things will ultimately end up. I think we'll ultimately end up in a place where there's no need to own a car, and you can maximize resource use. It's just much more efficient if you don't own a car. Because if you can just summon a car, like, if you can, like you use Uber or Lyft, if you can just summon a car anytime you need it, and a car will just show up and pick you up and take you wherever you need to go, you don't really need a car. And the car also, your car, I mean, our cars, like, they're expensive, right? They cost a lot of money. They cost a lot of money to maintain. And then driving them is hard, right? Like, people fall asleep, people get drunk. And then the cars are, like I said, most cars are idle most of the day, right? They're either in your garage or in your driveway or in a parking lot somewhere. And you're really only driving them a really small fraction of the day. So when you think about that, that's like a lot of wasted resources going into cars that don't really get used that often. So, you can reduce the number of cars on the road pretty massively, or reduce the number of cars out there, at least, not necessarily on the road, but you can reduce the number of cars in society if you change things around like this, if you go with a model where people don't need to own cars. You can change the way like cities are designed, because right now cities are designed for cars. Like if you look at where you work, or you look at like the supermarket, you look at how much space is actually devoted both to roads and to parking lots. It's an enormous amount of space. I think I saw some stats somewhere that parking lots alone are basically in the US account for space that's equivalent to the size of Connecticut, which is not a big state, but it's a decent amount of real estate that's devoted to cars. And you think also about like, in downtown core city areas where the real estate's really valuable, having space devoted to cars is not a great use of space, right? If you could have a system where you had remote parking lots that are really far, far away in kind of less valuable land or less usable land where a car is actually parked, and then you just summon the car when you needed it, could really change the way cities are laid out and designed.
I do have this fantasy of living in an autonomous RV that just like travels nonstop around the country, never stepping out of it. So I had not thought about the impact on city design, things like that. That's pretty amazing stuff.
Yeah, I think most people don't. I had not thought about it either until I saw Prezo on this, and they were kind of really pointing out to, like, if you really think about it and you go to that model where people don't need to own cars or just don't own cars, and cars can drive themselves, it really kind of changes the layout of things. It even changes the layout of freeways. Right now, freeways have to be designed so that they can accommodate a certain number of cars with a certain amount of spacing. But autonomous cars can actually know what every other car around them is doing because they can communicate. So, the car in front of you can tell your car that it's going to brake shortly and it's going to reduce its speed to a particular speed, and your car can then respond appropriately. So that actually means that cars can tailgate each other. Autonomous cars can reduce the distances safely between each other, and you need much more. The lanes don't actually need to be as wide, so you can actually like fit more lanes in a freeway, and you can fit more cars in a freeway in any given space.
I think you could even reduce drag that way too, right?
Yeah, you probably could. I hadn't thought about that, but there are environmental benefits as well. Those are less certain, but they're definitely environmental benefits because people don't drive in the most efficient way. So people speed, and I think I can't remember the exact stat, but like every mile over 55 miles an hour, there's like some sort of exponential reduction in gas mileage because 55 is the optimal speed. So yeah, if the car just drove a constant speed and didn't slow down or stop and speed up, they can actually drive a lot more efficiently than humans can.
What is your timeline for getting to a level 4 car? Are you guys already at sort of a level 3 or is level 4 in the works currently? Are you testing it or?
The design is a level 4. It's still being tested, so they're still working on it. 2014, we built prototype vehicles that were designed without manual controls. So they don't have steering wheels or brake pedals or accelerators. They're just like, there's just 2 seating positions and there's no manual controls. We have temporary manual controls in a center, in kind of the center well that the test drivers use. But the plan is to, once we can operate fully driverlessly, we'd actually remove those manual controls. So it's being designed to operate at a level 4 level.
I found some presentations by this Professor James Leonard at MIT, who had some really interesting things to say about autonomous cars. He says that his real dream is to build long-lived autonomous systems that can do lifelong learning, that can gather information over time and get better and better, and that can learn building underwater vehicles that never get lost, that go off and find information in the ocean and come back with valuable data. Is this sort of an area that you guys are thinking about at Google as well?
Yeah. So our cars are not there yet. What he's talking about is more of a dynamic intelligence. Our cars, they do learn in the sense that we continually program them. One of the main purposes of testing of like our operating our test fleet is that we get a lot of data back from that. So we get a lot of data on what other cars are doing, what other objects on the road are doing. And because the real challenge of a driverless car is predicting what other people are going to do and other objects on the road are going to do. That's the real challenge. Because, the human brain, when you think about it, we're actually really good at this stuff. And computers are actually not that good at it. Computers have to number crunch. So the computers are very good at doing a lot of calculations. They're much better than humans at doing a lot of calculations, just kind of with like brute force calculations. So they'll run through, a billion calculations, whereas a human won't run through a billion calculations because we'll know that 999 million of those calculations are irrelevant. A computer won't necessarily know that. They brute force everything. So for us, our brains kind of like very quickly figure out when we see a pedestrian on the side of the road, standing at a crosswalk, your brain just, unconsciously will make an estimate as to what that person's going to do next. I was just driving around earlier today and I saw a pedestrian who was at an intersection, and I was trying to figure out which crosswalk they were going to cross. Were they going to cross in front of my car, or were they going to cross parallel with my car's course? Because their body was kind of angled in a certain way that it was not really clear. So we're constantly making these calculations unconsciously as to what other objects are going to do. You're watching like cars in front of you and next to you, and you're kind of measuring how much a car on the freeway next to you is cheating over. And then you're changing the probability in your mind of like what the likelihood is of that car cutting in front of you. And then you take all sorts of other cues that we don't necessarily think about, but like you can sometimes see in a car in front of you on the freeway, like you can see the person looking into the rearview mirror, and that probably increases the probability that the person is going to change lanes. There's all sorts of things like that we take into account that you got to train a car to do. A lot of what we train the cars to do is probabilistic determination. So they have like very sophisticated algorithms that basically use all the data that we continually collect to update the software to better predict what other road users are going to do.
It sounds like your biggest barrier at this point in many different ways is the unpredictable human behavior, both from drivers and from people in the road, pedestrians. And then also, if you have a situation where there's like a police officer who's waving cars on, but there's a red light, but he's waving cars through the red light, or if there's a green light and there's a police officer signaling people to stop. Seems like these would be difficult issues.
They are really difficult issues. That's actually, one of the big challenges is actually addressing a lot of these issues. So we've trained the car to recognize hand signals from like cyclist hand signals. So if cyclists like signal that they're going to turn left, the cameras on the car are designed to pick that up. We've trained it to recognize like temporary stop signs. So, if you have like a crossing guard walk out with a stop sign or a slow sign, the car is designed to actually recognize that sign and respond. But it's a real challenge to do this kind of stuff because there's just so many variables. People aren't always dressed the same way, like, police, like a police officer directing traffic at a dead traffic signal. The police officer could be standing anywhere in the road. They may be dressed differently. They don't necessarily use the same hand signals, right? It's humans, right? They might just be pointing. They might be waving. They might be using any number of hand signals to indicate what they want you to do. And, humans were actually very good at figuring that stuff out very quickly. Well, maybe most of us, or some of us are good at figuring that stuff out. But whereas a self-driving car, you have to train it from scratch to try to figure that out. And that's definitely a really, really challenging problem.
Yeah. And then in Boston where nobody uses their blinker.
Yeah, no one uses the blinker. No one lets you in. Yeah, definitely true. And the drivers out here are also, they're pretty bad as well. You drove in Los Angeles, you know.
Yeah, it's awful. I think about some of these problems and I wonder if you guys have considered the idea of an external device for police officers or crossing guards or whatever that would then send a signal to autonomous cars to say what the directive was, as opposed to relying on the car.
We haven't gotten there yet, but I think that is probably where things are heading generally. Not necessarily for us, but like that's where the state of the technology is heading. So there's two technologies that there's a type of technology called vehicle-to-vehicle communication. We don't actually use that, but that's kind of being discussed a lot in the industry. And there will start to be protocols that are going to come out at some point, industry-wide protocols for vehicle-to-vehicle communication, where your vehicle will, without you doing anything, will basically transmit to other vehicles around your vehicle, kind of signal its intention so that those vehicles can take that into account. So what you're suggesting, that's a very similar issue. There's an initiative I think it's called the Smart Cities Initiative, where they're actually looking at this type of technology. So you would have traffic lights, stop signs, road signs would transmit to cars, and presumably emergency vehicles and emergency responders like police and firemen would probably also have some sort of transmitter device. This stuff isn't all worked out yet, but you can kind of see where it's going. So what you're saying, I think, is kind of where things are going. But, the infrastructure costs are probably pretty substantial, and there's not a great economic incentive to do that until there are more driverless cars, or at least more semi-autonomous cars, like level 2 and level 3 cars on the road. But I think when you start to see a lot of level 3 cars, at some point we'll hit some sort of critical mass, and those technologies will start to become economically incentivized.
Right. The other thing I'm wondering about is if you're considering the human occupants of the car as sort of an information resource. So like if the car gets into a situation, say it starts snowing or in a whiteout or something, and it can no longer identify something in the road, that it could then actually like just ask the occupants for help. to say, what is this and indicate the object?
We aren't considering that. Probably just for safety. Car makers probably wouldn't do that just because you don't really know people. Relying on people, it starts to become a little bit risky because you also don't know who's in the car. You could have blind people in the car. You could have kids in the car or drunk people in the car. So you don't really know. And if you can't control for that, then it would be kind of scary, if you were blind or something and your car started asking you, I can't see the road. Can you tell me what that object is? I think there's an object in front of our car.
These are very strange times that we're in. It's like we're in this weird transitional period where the main barrier are people. So like once all the cars become autonomous, we'll have reached a whole other level of economy and perfection in driving that we can then build on.
Yeah, no, that's exactly right. So that is exactly the problem that autonomous cars face. Oh, well, actually, there's two problems they face. One is figuring out what non-human road objects are going to do. So like things like, animals, road debris, like plastic bags, tumbleweeds, fallen trees, things like that. Figuring stuff like that out is one thing. But probably the biggest issue is just humans, dealing with humans and predicting what humans are going to do. It's really hard to do. And humans are very good at it. Like you read a lot of articles about self-driving cars in the press, and the ones that are pro self-driving car often start out kind of bagging on human drivers and how bad they are. And yeah, it's true. There's like 30,000 road deaths a year in the US. So there are some bad human drivers, but when you think about it, it's like you're driving a 2-ton vehicle at 75 miles an hour. So it's like an inherently somewhat risky endeavor. And there's just, millions of cars on the road. So when you think about it, actually 30,000 deaths is a lot, but maybe that's actually an impressive number. Maybe it doesn't really focus on all the normal trips that people take every day where nothing happens. So when you think about it, humans actually really aren't bad drivers, and they're actually quite good at very quickly figuring out and anticipating what's going to happen on the road.
And generalizing and predicting. So let's get into some of the legal issues that you've been dealing with so far. So how do you guys figure out fault when it comes to autonomous vehicles? If one of them gets into an accident, how does that get worked out?
Well, let me talk about like the way it would work, because right now it's pretty boring because it's basically the human driver of the vehicle. Even if the computer is driving, the human driver in the vehicle is going to be the one who's responsible. So that's going to be true in most states because most states don't have autonomous vehicle laws. New York is actually the only state that has a law that actually would preclude driverless cars. And it does so unintentionally. The law in New York is that a driver has to have one hand on the wheel at all times. So obviously, if you have a driverless car, that would preclude your car in New York. But no other state actually has a law that would technically preclude driverless cars. When legislatures were writing road laws, 100 years ago or so, no one really thought to say, hey, you have to have a driver because, well, there's really no need to say that.
Right.
Because it's kind of obvious, right? So they don't actually say that. So there's nothing really in most states other than New York that prohibits driverless cars. Now, the problem, though, is that in some states like California, Nevada, Florida, Michigan, and the District of Columbia, those states have passed driverless car laws. And so in those states, they require that right now that you can only test vehicles on the road. And when you're testing, you have to have a test driver in the vehicle. So in those states, there really isn't the option of fully driverless cars. But in the future, let's go, 5-10 years in the future when we're seeing level 4 cars on the road. That's a good question. It's one that the law hasn't actually addressed because it hasn't needed to address it, but they're going to need to probably make changes to the law, or they're going to need to figure out a way to interpret the law so that, you can actually apportion liability.
Are you anticipating any sort of like countersuits from drivers who get into accidents and then realize that they're deemed at fault, and so then now they're going to countersue Google?
That's probably something that's inevitable. The way things work in the US, the way the auto liability regime works is, fortunately, everyone's required to have auto insurance. And the auto insurance applies to the car as opposed to the individual. So, for example, if I were to steal your car and I crashed it, technically your insurance would still cover it because insurance in the US follows the vehicle as opposed to the driver. So what that means is that in an autonomous car, if we get in an accident with another driver, it's most likely that the liability is going to be covered by the existing insurance regime because our cars all have insurance, and by law, everyone's car is required to have insurance. I don't actually know the law in all states on insurance, but in California and Massachusetts, you have to have a minimum amount of insurance in order to register your car or drive. As long as the collision liability and medical liability is below a certain amount, like $250,000 or whatever the minimum liability amount is, then presumably existing auto insurance is going to cover that. So you wouldn't necessarily see lawsuits, hopefully. But it's true. I think at some point you could. If there is more damage, there just might be more liability if there's a lot of damage or
injury.
Yeah, a lot, like a very large accident with a lot of injuries.
What really amazes me about the technology is not, what's happening now is incredible, but I think about the fact that, every amazing technology 5-10 years later is outdated or it's completely commonplace. So thinking down the road that this autonomous technology is going to be ubiquitous, probably in 10 years, maybe. Do you think that we'll see a time when things besides cars will also be autonomous? Certainly in the hospital setting, it makes sense to have autonomous sort of orderlies, delivering drugs and so forth. I think they're already doing that with robots in hospitals. But why not autonomous porta potties at a concert event or something, or something that brings me my coffee, or you know what I mean? Why shouldn't my groceries be able to drive themselves to my house? I keep seeing an ad for luggage that follows you around the airport. So
I saw that. That is the most ridiculous ad I've ever seen. But yeah, the autonomous porta potty is a little frightening. I just kind of paused on that. That's a disturbing thought. There's definitely a movement in that direction. We have a drone project, and Amazon has a drone project for very fast local delivery. Because one of the challenges for delivery of goods is what's called the last mile challenge. And that is, it's really easy to deliver large quantities of goods long distances. You can pack a plane full of stuff, you can pack an 18-wheeler full of stuff, and you can take it from Tennessee to California in 3 days or whatever it takes to drive all night. That's a huge amount of goods that you can transport really quickly. But then the problem is those are all in that 18-wheeler, you have 1,000 packages that are each going to a different address that are a mile away from the hub that 18-wheeler got to. So that's the last mile problem. And those individual deliveries are very expensive because they take a lot of vehicles and a lot of people to actually do the deliveries. Whereas that long haul trucking route took one person 2 days or whatever to drive. So the last mile problem is one where if you did automate, you could get a lot more efficiency. So you can see drones are one option, and driverless cars potentially, if you had some way to actually deliver goods to people, are another option. You can think of many others, but you can see how robotics would actually affect kind of that problem. And there's a lot of similar problems like that, where there are a lot of tasks that you can automate, where you really don't need a human to do them. A lot of cleaning tasks.
Sure.
If you had robots just running 12 hours a day, say from the time your building closes down or the time the school closes down until 7 a.m. when it opens, you could basically have a robot running all night cleaning stuff. Those are tasks that you could automate, and that could be done a lot more efficiently.
Is Google working on indoor applications for this stuff?
My project definitely isn't working on indoor applications, but it would be a similar technology. It would be a lot easier to solve problems because you have far fewer variables, and hopefully the speeds are a lot lower indoors than they are outdoors. but you just have far fewer variables. So, indoors, you're probably just dealing with people as your only unpredictable, like pedestrians, as your only unpredictable objects. And those are a lot easier to deal with than cars are, especially at low speeds, because, it takes many feet to stop a 2-ton vehicle traveling at 30 miles an hour. So a pedestrian gets in front of it, or, some other object gets in front of it. That's a lot of energy and mass combining. In indoor applications, obviously the speeds would be way slower. The weights would be much, much lower, and you have far fewer problems indoors than you would outdoors. So there are certainly applications where, our program isn't working on that, but you can definitely see that stuff kind of coming.
How long do you think it'll be before we actually see networks of cars on the road that are all autonomous and all communicating with each other?
For autonomous networked cars, that's probably going to be a long time for a couple of reasons. One is, you have so many existing cars on the road. My car is like 10 years old at this point. Cars usually last around 10 years. So getting existing cars off the road is a long-term process. And then obviously like fully autonomous cars and even level 3 autonomy cars, there's still a long way to go, at least before you can get there in large numbers. So that'll be a while. But I think actually what you will see within the next 5 years, I don't think that's too liberal of a prediction. I think you'll see networked cars. So that thing I mentioned before of it's called V2V, vehicle-to-vehicle communications. That technology is much easier to roll out because it really just requires transmitters and protocols. So you just have to agree on a protocol for communication.
Do you think we'll see this first in like 18-wheeler trucks? I saw something the other day about the first 18-wheeler truck making like a cross-country delivery autonomously. That seems to be the biggest use case, I would think, for a truck that needs to travel for 12, 14 hours to deliver goods. And it's all going to be highway driving and so forth. Is that the lowest hanging fruit, do you think, for Google? I mean, to replace a driver who has to stop every couple hours, so forth, an autonomous truck could just keep going. And is it something Google's going after?
I think it's probably a potential option. We're currently focusing on the consumer and just sort of solving the technical problems, and then how it ultimately ends up getting productized. That's still, kind of an open question. But yeah, you're right. That is kind of low-hanging fruit. That company, I think probably the one you're thinking of is called OTTO. That actually was founded by a former member of our project. He left last fall and started Otto. And then Uber recently acquired Otto a few months ago. I think the ad you saw was they did some sort of partnership with Budweiser, and they did like a fake beer delivery. Or not a fake beer delivery, but they did they basically did a commercial.
Well, if it's Budweiser, it's pretty much fake beer delivery.
Yeah, that's true. Yeah, fake delivery of fake beer.
Yeah.
But that was basically a delivery of, they showed kind of what the concept of a long haul delivery would look like. It is low-hanging fruit. It's like these long-haul routes are almost entirely or possibly entirely freeway. The freeway problem is a lot easier to solve than surface streets because you just have far fewer variables. Most cars are heading the same direction.
Yeah.
You don't have stop lights. You really don't have that many road signs. You have like road signs indicating, geography and geographic points, but you tend not to have a ton of road signs that are traffic related. So like you have speed limit signs and you have merge signs and things like that, but it's actually not that many compared to surface streets where you just have a lot of stuff like crosswalks and school zones and traffic lights and railroad crossings, yield signs. And there's a lot of traffic signs on surface streets that you don't have on freeways. On freeways, you don't have pedestrians, you don't have cyclists. Really the variables are far, far fewer. So they're actually, other than the speed, freeways are actually pretty safe.
I can imagine that network security is a huge issue with these things. We just did a podcast with James Plouffe, who's a solutions architect with Mobile Iron, and he talked a lot about the biggest sort of enterprise security threat as being the Internet of Things, where we have all these end devices out there that have, sloppy firmware that can't be updated. How is Google handling the issue of security and, autonomous car hacking?
So the good thing about our program is that Google, because of its core business, it's just hyper focused on security. It spends an enormous amount of money. It has on security, on internet security, on encryption and user account security, data security. So the car, when we designed the car, it was really designed kind of from the ground up with security in mind, because the company really didn't know a lot about it, was really focused on it. The danger, I think, is in existing car manufacturers are way behind the curve on this, and they've just really recently woken up to it, because there was a hacker who recently hacked into I think it was like a Jeep Cherokee, hacked in and was able to actually basically take control of the car. Was able to actually control acceleration and some other functions.
Yeah.
I think there was a USB port in the radio, and they were able, I think, through that to access what's called the CAN bus. Modern cars have buses that allow access to different systems of the car. And so I think they were able to access it through that port in the radio. There's definitely a lot of concern about security, but we've kind of focused on that from day one. But existing automakers, I think, there's a lot of focus on autonomous cars and security, but it's kind of funny. I would say it's actually not an autonomous car problem. It's a vehicle problem. It's a problem that applies to cars generally.
Yeah.
And autonomous cars actually are probably better suited to avoid that kind of stuff, because they've kind of had to design with that in mind, whereas existing cars really aren't designed with that in mind.
Right.
Until now.
Right. They began with security in mind rather than sort of bolting it on later. Yeah.
Yeah, exactly. But yeah, that Internet of Things problem. I think that there was that recent DDoS attack a couple weeks ago. It took down a lot of Netflix was offline for part of much of the day.
Yeah, we were. It took down some of our cloud service. It took down our box service.
And that attack was initiated through networked home security devices. Basically, the hackers were able to download or upload malicious code to thousands or millions of devices like that, networked home security devices. And then apparently that is actually the method of infiltration that they use. So yeah, it is definitely that. It's kind of a scary thought that there are all these devices out there that really haven't prioritized network security, and they're all networked.
Right, exactly. What really excites me about this is just from a design perspective, so much of today's car designs are based around safety. But in the future, if all the cars are networked together and they're all autonomous, we no longer have to worry about designing for safety. So theoretically, cars could go back to looking like the way they did in the 1920s.
That's a great point. I actually had not thought of that before. That's the first time I've heard that. But that is a very good point. People have talked a lot about how cars could be redesigned in the interior. So you could have just completely different layouts. You don't actually have to have a driver position. So you could have seats facing each other.
Right.
Mercedes designed a concept car recently. I think it's probably on their website, but it's really cool inside. It has basically the steering wheel and controls recede into the dashboard. And I think the seats swivel around, and there's a table that pops up or something, and it almost looks like a living room or something. It's kind of cool. And you can redesign and reimagine the interiors of cars. But actually, that's the first time I've heard someone say you could redesign around safety. And I think that's probably true. You probably could. You're right. A lot of the shape of the car, of current cars, is designed based on safety. So you have crumple cans in the front of cars and, crumple zones. And the chassis are designed around protecting vehicle occupants. You could probably reduce the weight of the cars a lot as well, which would be a lot more efficient for, energy use. And you could probably do something as well around wind resistance, since you're eliminating certain features of the car that are needed for safety.
People will be getting more work done in their cars. They may not be as inclined to need to get places quickly. I mean, they may be able to get places more quickly anyway. So it's just an amazing, exciting time to be in. And it's such a weird transitional period where we're sort of our own barrier.
Yeah, it totally is. And we're kind of at the very early stages of it. There's, I think, a lot of confusion out there about Tesla, in particular because they're very adept at marketing their system. But if you actually look at their filings, they're very, very clear. They actually say they're a level 2 system. So in their filings with the National Highway Transportation Safety Administration, they actually sent a letter to them recently because NHTSA is the body, it's called NHTSA, that regulates, at the federal level, regulates auto safety. And so they, after that crash that Tesla had in Florida, where one of their cars crashed into a truck and the driver died, NHTSA started an investigation. I'm not sure if it was part of that investigation or what the context was for Tesla sending NHTSA a letter, but in the letter, they actually say they're a level 2. I know that NHTSA and state regulators, so in California, the DMV is working on operational regulations for autonomous cars. They're both actually pretty focused on this issue, in part because of Tesla's accidents and Tesla's marketing. I think that, I think the reason a lot of people out there think that it's that it's a level 3 car, or that even Tesla owners are willing to actually just go, do really stupid things under the assumption that the car really is going to drive itself. I think the regulators are starting to get really focused on this. Something is going to happen. They're probably going to take some action. In fact, I think even in the proposed operating regulations that the California DMV recently came out with, they have some prohibitions around marketing of autonomous vehicles and what you can say and what you can't say because of that, because they're concerned about people having false confidence around the handoff. I think there's studies that show it takes the average driver 8 to 10 seconds or something to actually figure out what's going on in situations where there is a handoff. So you think about that, if a car is driving at 70 miles an hour, 8 to 10 seconds is that's an eternity.
Yeah.
Something is going to happen in that area.
It's so interesting that we've become so accustomed to adopting technology quickly that people are willing to adopt the riskiest technology, even though it's not even there yet.
I'm going to call this the iPhone phenomenon.
Yeah.
People they don't know why the thing works the way it does. They just know it's magic. I mean, it works incredibly well, right? The iPhone's just a really beautiful phone that really works well, and they work intuitively at predicting kind of what you're going to do and what you're going to say. And people unfortunately get used to that. They don't really delve into the technology and what's powering it. And you can kind of see that in this space because you're actually dealing with people's lives. It's a lot more risky than just a phone or just a computer or something. For example, Tesla's vehicles, they rely mainly on cameras and radars. And the problem with cameras is that they can be heavily subject to conditional-based errors. So if it's very bright out, the sun is at a particular angle, it's like the human eye, right? It basically gets blinded. You can get blinded by glare. It's hard to discern the color of traffic lights if the sun's shining on them. Cameras have the same problem that humans do, basically. And so if you're relying on a camera system, and I think that's actually what happened in that Tesla crash in Florida. Apparently, the truck that was turning in front of this guy, I think, was white, and the sun was shining on it at a particular angle. And I think the vehicle may not have picked it up, or at least didn't pick it up in time. That actually was, part of the problem. Cameras they're inexpensive, but again, that's why Tesla's saying theirs is a level 2 system because it really relies on cameras and radars. You kind of have to have a much more robust sensor suite in order to really image the vehicles around you and people and cyclists and all the objects around you. So people don't really delve into the technology that's powering their car, and they just assume, it must work. People are not good at statistics, so they're not good at, if the car operates well in 90% of situations, they just kind of assume it operates well in 100% of situations. And so whereas in 10% of situations, it may operate terribly or not operate at all. So that's kind of a human statistical failing.
And so how much of an autonomous car's abilities is based on sort of live information versus information that's been gathered by other drivers driving on those routes and mapping the areas? Is it 50-50 or?
For our system, it's both. The actual breakdown would vary depending on the circumstances. But the way the Google cars are designed to work is we basically do highly accurate mapping of whatever the territory is we're driving in. And then the cars navigate and basically drive on the center of the road based on those maps. So that sort of driving is done based on the maps, but then it basically takes into account imagery that's generated dynamically. So as it's driving, it's constantly imaging the area around the car on the road, and then its behavior with respect to those road objects is done dynamically. But the driving itself, like the navigating and actual like driving on the route, is done based on maps.
I see.
Most companies don't do mapping. I think Uber does. Uber's car is like our car. They use similar technology. If you read like the tech press, there are a lot of predictions about how quickly that the technology is going to roll out really quickly. I don't know. I saw some technology article recently that was predicting that like in 5 years or like by 2020 or something like that, like no one's going to own cars. Like all cars on the road are going to be autonomous. I was kind of laughing at that. We're at the early stages, and I think it's going to roll out probably relatively gradually, and it's going to probably be over a fairly long period of time. So that's my prediction. There's a lot of tough problems to solve. You mentioned weather, like, what you do in snow and inclement weather. And then, of course, you have the human barrier. And then you have regulatory barriers. I mean, that's kind of what I work on. There are pretty significant regulatory barriers to doing this stuff. And the regulatory apparatus in the U.S. and states tends not to move that quickly, especially at the federal level. It moves pretty slowly. And, especially when you're dealing with like a safety critical product, things move slowly just because people want to make sure it's safe, right? There's also a lot of fear out there. If you look at polls, they're kind of all over the place, but there's actually a significant number of people that still say like, oh, they would not want to ride in a driverless car. Or they don't want driverless cars on the road, or they're afraid of them. There's a lot of like public perception barriers to get over. Until you get over those, it's probably going to be hard to tackle the regulatory barriers because you got to solve that problem and get people comfortable with the car. The system Tesla used to use was actually a system created by an Israeli company called Mobileye. And they recently, like within the past 6 months, right after that Florida crash, like a couple weeks later, I think they terminated their relationship. The Mobileye system is like camera/radar based that's intended to be relatively inexpensive, and it's not available as an aftermarket thing right now, but my guess is that's where it's headed. And then there was a company called Cruise, which I think was actually started by like an MIT undergrad, and I think it may have been based in Boston, and probably still is. It still exists, but I think it was bought by GM, and that actually was an aftermarket system, and it was designed for one of the Audi cars, I think an A4. And it was meant to be an aftermarket system. And I think their goal was like, it was supposed to be like a $10,000 add-on. So you literally buy this like $10,000 add-on to your car and have it installed, and it would operate autonomously in limited situations. So I think it was probably an L2 car, but it's still, there are companies that are definitely thinking about that.
I think it would take something like a conversion kit that you could buy for like $50 that they could install at Jiffy Lube in 10 minutes to turn any car into an autonomous car. I think it would take technology that was that transformative.
I think you're right. When you get to that point, that's going to be like super transformative.
But in the meantime, a huge hump. Well, Anand, thanks so much for hopping on.
Yeah, sure.
And
this is fun.
Thanks for tuning in to another episode of Device Squad, the podcast for the mobile enterprise from Propellix. All right, man, let's keep in better touch, and so let's not make the next time we talk be from our autonomous cars.
Yeah, let me drop you a line. It'd be good to meet you.
Yeah, perfect. All right, take it easy. I'll see you soon.
Okay, see ya.
All right, buddy. Bye-bye.
Bye.